first webinar series about data material resources. I am honored that this first webinar is about RaDiCo, and I will let Carl make the introduction about this webinar series. So it's to you, Carl.
Okay, thanks, Daphne. So thank you all again for joining this series of webinars. So in these webinars, we will show different resources or platforms that are working in the EJPRD project. Some of these are mainly centered on helping to study rare diseases. Others are introducing tools for this to adapt them, the resources to the rare disease to study rare diseases. And this is please, if you can mute all yourselves, thanks. So the idea is to have one webinar each month. I don't know if there is a general agenda of all the webinars that will be there for the next months. If not, we'll post it soon in the EJPRD website. And the idea of these webinars is for you to know first what is the resource that we'll be presenting, what do they do, how can it be helpful for the clinicians and researchers that are studying the rare diseases, and how can them be used by these users, these clinician researchers. So that will be it, and Daphne, please begin. Thanks.
Thank you, Carl, for this very good introduction. So I will begin with the presentation of RaDiCo. I am Daphne Jawi, and I am e-health project manager at RaDiCo, which means Rare Disease Cohort. So to introduce the RaDiCo resource, I have to introduce how the rare disease healthcare network is organized in France. So in France, since 6 years, the rare disease healthcare network has been installed in France, and it is supported by the French Ministry of Health. And it is around the construction on 23 healthcare networks. Each healthcare network is covering a group of rare disease, and each of these 23 healthcare networks are connected to coordination centers. These coordination centers are covering rare disease or group of rare disease, and they are specialists and experts about this group of rare disease. Each rare disease coordinating center is related to 386 constitutive centers that are specialists for one rare disease, and each constitutive center is also connected to competence centers. These competence centers allows the medical network to cover the French territory, and so all patients from all France can connect to medical centers that is specialists concerning a given rare disease. Concerning the link between this organization and the European organization, each of these 23 rare disease healthcare networks are also related to the European reference network that we know today. So how does it has been built in France? So RaDiCo and National Bank for National Rare Disease Bank are two complementary programs. So the National Rare Disease Data Bank is about public health. It has developed the IDMR, the Rare Disease Patient Identification Code, and it is about the collection of a minimal data set for each patient concerning its disease and its identification, and its wish to cover all rare disease patients. Concerning the RaDiCo, the rare disease cohorts, it's about research, and it has been built related to the rare disease healthcare network to make cohorts about a set of patients that has been selected according to inclusion criteria. And it is a longitudinal for longitudinal follow-up studies. Knowing that, we identified issues concerning the research about rare diseases, the clinical research about rare disease. These issues are the next one, as you see in the screen. It is, for first of all, the limited knowledge about natural history of rare disease, the clinical and genetic heterogeneity, the pathophysiological mechanism that are poorly understood, and cases that are mostly prevalent, and very few incident cases. We have also numerous expert teams scattered around, knowing healthcare, research, patient association, that not very well from at the beginning, less now, but they are not very well coordinated. And also, there is a heterogeneous and local information system. We have also limited use of standardized coding, clinical and biological science, and ontologies. And we also faced the poor integration of key data source, clinical, biological, biobanking, multi-omics, patient reports, outcomes, and etc. And finally, we have almost no connection between existing databases. To answer these several issues, there are the scientific objective of the RaDiCo program that has been set up. So to cover these issues, we set up several rare disease e-cohorts ex nihilo with the following aims. So understand the natural history, understand also the genotype-phenotype correlations, the pathophysiology, select eligible patients for new therapeutic approaches, install new therapeutic avenues, know more about the societal and medico-economical impact, and finally, set up methodological strategy for analyzing cohorts combining prevalent and incident cases, modeling bias analysis. To achieve this goal, so we built a national operational platform, which is equivalent to an infrastructure as a service, and which is for implementing, theoretically, a non-finite number of e-cohorts with prevalent and incident cases. So now is the presentation of the RaDiCo cohorts. Nowadays, we have 13 ongoing RaDiCo e-cohorts involving 67 rare diseases, and for now, we have 5,826 patients. Here you can see the 13 rare diseases. For example, we have eye congenital defect, the RaDiCo cohorts, which name is Accueil. And we can see also the French Rare Disease Healthcare Network, and also the relation to the European Reference Network, the ERNI. For example, concerning the cohort Accueil, we are covering the study of 5 diseases that are anophthalmia, microphthalmia, aniridia, Axenfeld anomaly, and anomaly of Peters. So to follow this all diseases and cohorts, we built the RaDiCo platform with several specifications. Concerning the platform building principles, we followed the factorization principle. Theoretically, we can integrate a non-finite number of cohorts. The mutualization, we have one informatic system for all e-cohorts. The industrialization of processes and automatization of the system. And we have also the data quality control. Concerning regulations, we are okay concerning the GDPR and also concerning the privacy impact assessment, the PIA security, concerning the informatic system that are hosting medical data. Concerning the means that we used to build the RaDiCo platform, we used cloud computing infrastructure, as we set up it as infrastructure as a service, and we did try to set up interoperability when building this informatic system. And we present now in our teams mapping data expertise. Concerning standards that we are using, we are in a work to do the standardization using with covering a CDISC expertise. And concerning the verification, we are ongoing on this point using semantic standardization and using REDCap, which is, and I will say it before, after, which is compatible to fair data transmission. Concerning exchange of our data with several national organizations, we are able to do the data exchange with France Cohort, which is the French big organization of all cohorts, not only rare disease, that will be installed in the next few years in France. We are trying to install the connection to the National Health Data System, which is collecting all health data concerning patients all over France. Not clinical health data, but only medical prescription, I have to say. We are also trying to set up the Health Data Hub connection, and finally, we are also part of the European Research Network as a cohort and not only as an informatic system. So, how is the RaDiCo information system? How have it been built? So as you can see, it has the particularity to be set in two parts. The first part is on the cloud, Microsoft Azure. And in the first part, we have the back office, which is covering the user access management. Concerning the other part, it is hosted in the CGM servers, and CGM is for Compute Medical Group. Compute Group Medical, sorry. And this is a certified health data host. In this health data host servers, we set up the physical separation between patient identity database and patient medical database. So this patient identities in patient medical database are orchestrated by the EGCS, which is a server making the mapping between patient identities and medical data. And this is in order to present medical data to people that have the authorization to see the medical data, knowing that only the doctors and the investigators can see the medical data of a given patient. We're also presenting a dual authentication, which is compulsory in an information system that is hosting health data. Concerning the data collection functionalities, we have set up in RaDiCo as a tool which we call it PIST, for Patient Identification System Translator, and this PIST allows us to create and search patients. Patients are created knowing several compulsory data. Data concerning the first name, the last name, the birth date, and the gender. And finally, the system will attribute to the patient a RaDiCo patient number. It is a tool which has been added through a tool that we named the hook, which help us to add functionality into the pro software that we have, which is RaDCap. So place to the demonstration, we will see patient creation and inclusion, for example. We will see inclusion criteria and the different tools that we use to collect medical data. So I will reshare my screen to another tool here. Okay, so now you can see all of my computer and when I'm changing the windows. So here I am a given user, and I will go. I am in RaDCap, the RaDCap ProLogical. So we will see the page, the RaDCap homepage. Here I have the cohort I want to go in and in which I want to create a patient. So to create a patient, I'm going to the PIST through add and edit record, and I will create a patient, which name is patient. I will give a birth date, a gender, and add the patient. The first step is to confirm that I have given the good information concerning this patient. So I will verify. And if I do not agree with what I have written, no data will be registered if I click on cancel, and I will add, for example, S here and try to add my patient. When I add the patient, I will confirm the patient identity, and I will include the patient in what we name inclusion group, which is also for clinical research, the center where the patient is followed. So I will add it for me as an investigator, and I will confirm the patient creation. So in our databases, the patient has a first code, and it will have also a second code, which is named is the eligible code. Now the patient is created in the database and in RaDiCo, and I will recruit this patient and confirm this patient is covering the rare disease criteria and the inclusion criteria concerning this study. So it is in French. I will just fill in the blanks and, for example, propose a rare disease here. And here we can see it is interesting to see that we have a metadata base to which we can connect and add the orphanet name of the disease. So, for example, here I have set albinism, and it will search into the orphanet. It is an example, it's not a super patient, do not worry, and it is in the environment of test. So it's not in the real database. So the patient, we will say yes for inclusion criteria, and also it is compulsory for patient to have signed a consentment, and we will add the consentment date here. And here I will add the acceptation, the patient acceptation concerning data concerning recontacting the patient, and also data sharing with other institutes that are studying the same cohorts. I will set complete, and as you have seen, this button appears when all the criteria are fulfilled. Okay, it does not appear when if I do not have, for example, a consentment status and a consentment date. So I will click, and as you can see, the patient has first eligible number, and it will have also a final RaDiCo number. And now the patient is included into the database. Concerning the, so we have seen patient creation and inclusion criteria, simple and repeated instruments. So when a patient wants so when for a patient we have several examination, we can add several data for the same formula. So for example, I will set up that the formula is realized here. I will add a date. I will fill the formula, set complete, and save. Okay. Ignore and leave. And for example, if the patient has another genetic examination, I can add another, I'm sorry. It's not this one, sorry, it's the other one which is repeated. Yes, and now, which is interesting, that we can add another examination by clicking on plus here and adding, and it is for example, for drug taking or any other treatment, we can multiply as much as needed the patient examination, the formula. And here we see that we have multiple formulas that have been filled concerning this patient. And the formulas are also presented here. The other interesting setup that we can do in RaDiCo, it is the fact of setting longitudinal studies. So concerning longitudinal studies, here we have an example. We can see the data collection instruments here, and here we have the events. So we have the inclusion visits and the following visit at 1 year, at 2 years, and several formulas here are repeated during several years, and the whole follow-up concerning this cohort. I must say that it is this example is a true cohort formula that we have in our database. And knowing that, we can see that we have a tool here which is saying to me as an investigator when I will have to see patients. So, for example, I will go to the year 222, for example, and see if I have patient to re-see. No. I will go back. Maybe I will see something. But automatically, when I create a patient, the system will give me an announcement saying that I have to re-see this patient for several, and that I have to collect several data. So it is an important tool in our informatics system, which is proposed by RaDiCo. And finally, we have also the survey mode in which patients can directly answer to the form, and the investigator can send to the patient only an URL address, and the patient just have to click to arrive into the formula and to fill it. We also are working about installing multilingual mode, which is proposed by RaDiCo, as you can see here. So I go back to the presentation. And finally, we have seen how to collect data in RaDiCo. And I have shown how we collect metadata. So what is a metadata? Metadata is a data about another data. It's the case, for example, for ontologies. Ontologies that we use in our rare disease cohort are orphanet, HPO, that you know, human phenotypical ontology, and also MEDRA and the French drug ontology, which is Teriac. The use of metadata is supported by RaDiCo using this action tag, this sign here, and with this sign, when setting the study, we can tell RaDiCo, now you have to connect to this metadata and propose the metadata to the users, just as I did concerning the orphanet data in the last demonstration. So I have already done this demonstration. We can go to the next slides. Concerning interoperability, we have two types of interoperability. We have the informatical interoperability with data exchange, and we have also the ontology and the semantic interoperability. CDISC concerns for us the semantic interoperability, as far as CDISC is setting up a set of procedures and of nomenclatures to name all the variables. And when naming this all of variables following the CDISC nomenclatures, we can exchange our data and be comprehensible with other studies. Concerning informatic interoperability, IHE and HL7 are also informatic process to send data from one study to from one tool to another one, and it is supported by the RaDiCo tool. So it is interesting to see that finally the most difficult to install it is the semantic interoperability, as far as the informatic interoperability is rapidly installable. We also developed in our team a mapping programmation expertise. So we can do mapping to transform our databases from one e-case report form, ECRF, to another one, and transform the data. So what are the tools that data managers are using? So we have seen first the tool that investigators, clinical research technicians are mostly using, and now we will see what are using data manager to do ECRF conception, so e-case report form conception, and also to do data quality control. So RaDiCo is proposing a tool for study design to do set draft case report form, and in RaDiCo we have three important documents which will help us to build studies. So I will show you, as it is a demonstration, the three how to build a study into RaDiCo. So I will go back here, but now I am not an investigator. I am a data manager, and I will be able to go to the project setup. So the access right management is managed also in RaDiCo. As you can see, I do not have the same rights if I am an investigator or a data manager. And I will go to the data dictionary. So the data dictionary is the first document that RaDiCo presents, and this document is recapitulating all the ECRF. So if I click on download the current data dictionary here, just a few seconds, we can see all the fields, all the formulas, all and all the information that are coded into RaDiCo. And it is very useful for the data manager to see that and to have that, because, for example, I can see here the variable name, the form name here, and finally here we have the section header, for example, first form to fill, or which is important, the field type. Here it is text, Here it is drop down, which is a menu that is dropping down. And after we have the choices, the calculation, or the slider labels. For example, in the menu, it is set that we have first the name Bobigny, after the second name is Bordeaux, and etc. So it is very useful. And the other thing that is useful here is that I can also upload a data dictionary into the study that we have here in RaDCap. And to have the access to upload another data dictionary with several modifications, I can enter draft mode here. And I have the option of upload. And it is interesting when I have to copy one study in another study in RaDCap. It is very easy to do this. Also, I have another tool to build a study. I have the online designer. The online designer, it is the human-machine interface, which is helping me to build easily. It is very really a tool to build easily the study. For example, here I have I will do this. For example, I will go another one. I will copy past this, for example, this field here that we have seen when creating our patient. It is the classification according to orphanet. Yes, copy field. And if I want to change this field, I have here the field label. I can set up the file type and all information I have to see here, if the field is required, if I have an identifier here, and etc. So I will put also a 2 here and save. And when I check into the formulas here, I will go, for example, in a patient data. I will see that my field is copied 2 times normally. Not here. Maybe I have to do that. Maybe when creating a patient.
Sorry, Daphne, but you are muted.
Yes. Thank you. Daphne, I think if you can hear us, you are muted. We do not hear you anymore.
Oh, okay. Since how much time? Just now?
Around, yes, 2 minutes before.
Oh, okay. Thank you.
Thank you.
So yes, I will recreate the patient to see that so I understand what is going on. I have to accept the modification to see it into the formula. So it's okay. I will go back to the project setup here, go to the online designer and submit change for review as I have the administrator access. Not everyone can do this. Close, go back to a patient data. And here I see in a patient data, for example, here, that my field is created, and when it's created a second time. So here is the use of the online designer in RaDiCo. So I have the data dictionary, and if I want to build a longitudinal study, I will do also the set up the events and the mapping between the forms and the events. So we will see that. And I think it is my last demo concerning the time. I want you to also have the opportunity to ask questions. So I will go back to the project setup here. And I see that I have the opportunity here to define my events. Here I have the events and the time in days at which I want these events to appear in the patient agenda. And I can also set up not the events, but the mapping. And here I can set up. So here we have the forms that we have set in the data dictionary. And here we have the events. And I just have to set up the mapping here through the upload of an event map, instrument event mapping. And I have my longitudinal study. So now this demo is over. I will go on. So I will not have time to show very well the data dictionary, but we will see very fast. So the data quality, the data quality is the tool to see coherence rules over the study. So data quality allows us, for example, to see missing data. Here, for example, I will execute this rule, which is looking for missing data. So it's a test study, and it is saying me, you have 3,000 missing data, and for each group, you have the number of missing data, for example. After, we have also the tool which allows us to do reports. So here, for example, I have set a report to see the included patient. I have the number of included patients, which each patient formularies and ICRF. And I have added a report about the completeness of the forms, and etc. So it is interesting to see that I have the tool to create reports, to create reports and also to consult and to see in real time what are the numbers in these reports. We have also a tool to submit queries. When I am a data manager, I will submit queries, but I will not have time to show this. Submit queries to investigators when there are, for example, missing data. And we have process concerning, finally, the data quality management. We also set, through the tool Power BI, key performance indicators that are covering all the studies. And with this dashboard that we can see here for a given study, we can follow the patient number in the study, the included patient number, and finally see for the months, the new patient, for example, recruited in September, the total recruited patients, and etc. So it is in real time, and each time we go on this tool, we see the real number for all the 13 studies that we have, and it is a centralized project. Finally, it is the end of the presentation. We can say that we are using REDCap with RaDiCo specific tools, and these RaDiCo specific tools are allowing us to do ECRF conception, data collection, to follow the data quality, and to have reports about our data and statistical reports, but also figures and histogram and etc. to see how is the study and how is advancing the study. We also have that I have not especially presented it, but you have seen that we have administration tools and security tools. Also, not everyone can do everything in the REDCap. It is we have the user access management. We have a logging tool. This logging allows us to see all the activities of all the users in the study. And finally, we have also a tool for data modification history. We are also having the benefit to work. Sorry, I have problems with my. Yes. Okay. To work with the tool REDCap. And this REDCap allows us to benefit the REDCap users community. So concerning joining RaDiCo, if you want to build a cohort with us, you have the possibility to make a public-public partnership, but also a public-private partnership. And a new cohort project can be submitted to us through the address that you can see. And what is RaDiCo? Finally, what I have not presented, it is that RaDiCo, it is a complete team for clinical research. So we have clinical research project manager, data manager, statisticians, and e-health project manager, such as me. We also have 5 steps and a procedure to build a cohort. We are accompanying the cohort construction through the protocol writing, the ethic and regulation checking, and finally the ECRF conception and agreement, the cohort follow-up, and finally the data management and data analysis actions. So in terms of sustainability, you have to see it also financially, that to enter to RaDiCo, you will have to all of this service, and including the platform, and but you have to make it supported by scientific financement, for example. Finally, the takeaway message are that RaDiCo is 13 to n e-cohorts that can be built. We are nowadays we are actually following 67 rare diseases. We have 5,826 recruited patients, and our platform is respecting medical data hosting regulations, such as health data hosting and also general data protection regulations. I want to say thank you to, first of all, to Sonia Guéguin, which is the scientific director, scientific and operating director at RaDiCo. Also, thank you to Tariq Belkacem, which is here normally, and also to the coordinating committee for RaDiCo, Paul Landé, Serge Amselem, and Annick Clément. I want also to say thank you to the IT and e-health team that you can see here, the clinical research team with clinical research project managers, but also the clinical research technicians and clinical research assistants. And finally, the biometrics teams that you can see here with data managers and also statisticians, and also the executive assistants, Claire Pouillet. So thank you also to everybody to have followed this presentation.